Free Physics MP3 from cg4u.net for students. Source: Wikipedia. Newton's law of universal gravitation. Newton's law of universal gravitation states that every point mass in the universe attracts every other point mass with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Separately, it was shown that large spherically symmetrical masses attract and are attracted, as if all their mass were concentrated at their centers. This is a general physical law derived from empirical observations, by what Newton called induction. It is a part of classical mechanics, and was formulated in Newton's work Philosophiae Naturalis Principia Mathematica. The Principia, first published on 5 July 1687. When Newton's book was presented in 1686 to the Royal Society, Robert Hooke made a claim that Newton had obtained the inverse square law from him. See history section below. In modern language, the law states the following: every point mass attracts every single other point mass by a force pointing along the line intersecting both points. The force is proportional to the product of the two masses and inversely proportional to the square of the distance between them, where F is the force between the masses, G is the gravitational constant, m1 is the first mass, m2 is the second mass, and r is the distance between the centers of the masses. Assuming C units, F is measured in newtons n, m1 and m2 in kilograms, r in meters m, and the constant G is approximately equal to 6.674 times 10 to 11 nm2 kg2. For the value of the constant G was first accurately determined from the results of the Cavendish experiment conducted by the British scientist Henry Cavendish in 1798, although Cavendish did not himself calculate a numerical value for G. 5. This experiment was also the first test of Newton's theory of gravitation between masses in the laboratory. It took place 111 years after the publication of Newton's Principia and 71 years after Newton's death, so none of Newton's calculations could use the value of G. Instead, he could only calculate a force relative to another force. Newton's law of gravitation resembles Coulomb's law of electrical forces, which is used to calculate the magnitude of electrical force between two charged bodies. Both are inverse square laws, in which force is inversely proportional to the square of the distance between the bodies. Coulomb's law has the product of two charges in place of the product of the masses, and the electrostatic constant in place of the gravitational constant. Newton's law has since been superseded by Einstein's theory of general relativity, but it continues to be used as an excellent approximation of the effects of gravity. Relativity is required only when there is a need for extreme precision, or when dealing with gravitation for extremely massive and dense objects.